All right, for question number 12, one of the reasons why uh, it shows up as a question mark here is because, one, you guys are kind of further removed from this process, and two, we've done something else that we can find more information about these triangles. But if we're told, and I'll just take the first example here, if we're told you want to classify this by their lengths, so, or you're going to classify this figure as either acute, obtuse, or right triangle. And you don't have to actually find what its angles are. And because you could, right? You're given three sides, you could use SSS and find all the angles. And so that's one potential way you can approach this. And some people have. Which angle would you need to know in order to determine whether it's acute, obtuse, or right? Celeste. Yeah, so if you were to just think of this as 11, 15, and 18, if you solve for x here, it's going to tell you. If x is 90 degrees, then you have a right angle. If x is greater than 90, it's an obtuse triangle. And if x is less than 90, it's an acute triangle. Okay, but you don't even need to go through that step. Again, like I said, you can do it if you want, but the easiest thing is this is the process where you take the sum of the squares of the two smaller sides, compare it to the square of the longer side, and now you can just identify, is it acute, obtuse, or right? So if we took 11 squared plus 15 squared and compared it to 18 squared, okay, so you get 11 squared, which is 121. You get 15 squared, which is 225. And when you compare those to 18 squared, which is 324, what you see is that this sum is greater. Okay, and so again, if you can remember what I talked about when I compared these. And so your two sides are going to be the same. What you want to see is what kind of angle has to be formed here. Well, if our longest side squared is less than it would be in a right triangle, that means instead of this length, it's something smaller. Okay, but the two sides wind up staying the same. What kind of a triangle is formed? Acute. So we can label this or categorize it as an acute triangle, and based just on that. Okay, so again, if you remember on those, you have the three cases. If the c squared value is smaller, then it's acute. If they're equal, it's a right. And if the c squared value is greater than it would be in a right triangle, it pushes the angle out and it's an obtuse triangle. And so again, I'm not going to do B and C on that, but the process winds up being the same. Again, or you can use law of cosines and actually find what the largest angle is.